Next, we're recording again. Excellent. So now, as I kind of showed the last time, it's gonna get real tedious to enter in a ton of points that way. So let's find a better way. Let me share my screen. Awesome. Here we go. So what's going to be given to you? The benchmark elevation, instrument location, just going to give you an idea of the location of your topo, and you're going to get your vertical distances, horizontal distances, as well as your angular measurement in terms of degrees, minutes, and seconds. So I guess the first thing to point out would be it's going to be a lot easier to input things into AutoCAD as a single line. As you noted before, I entered in the word point, then I entered in the horizontal distance, then I entered in the angular distance, then I pressed enter. But you can also do everything as a single line. So what we're going to do is we're going to create a single line of text that has all of the data on it. And the way that we're going to do that is by converting our degrees, minutes, seconds into decimal degrees and an associated, I guess this is my easting and northing. Sorry, everyone. And an associated easting and chat. Is this Excel available now? No, I will be posting this. So, yeah, I'll post it with all of the actual data inside. So I will give you a version that has all of the actual data over here, but you're actually I'm not gonna give you any of the equations. You're gonna have to work on Excel in order to get all of your decimal degrees and coordinates and elevations correct, as well as using the concatenate function, concatenate, in order to create a single line of text that you can enter into AutoCAD. So what's that going to look like? Well, the decimal degrees isn't too bad, right? We know how to do that. And I'll just show you the equation right here, so you can come back to it later. If we want this in decimal degrees, it's just our degrees plus our minutes divided by 60 plus our seconds divided by 3600, and enter that in. That converts it to decimal degrees. Now, if you have a bunch of data, you can just double click on the bottom right-hand corner and it'll carry that equation down to every single cell. Or you can drag it down if that's your jam. For the elevation, is everyone, let me get an idea. Who's like super familiar with Excel? No problem. They understand absolute references. They understand everything. And who is like never, or really minimally half? Okay. Yeah. You know a few things, we don't know everything. Such as life. Cool. I just don't want to like over explain. Excellent, cool. I just don't want to like go over a ton of stuff that and everyone's like, how, like, why are you telling us this? Cool. Victoria with the, so I'm old and I only recently realized when people type in a chat little up arrow, it means they're referring to the thing above them. And someone told me that and I was like, well, duh, that's really simple. But I didn't know that until recently. So you could say I'm pretty hip. I cracked myself up. So awesome. So let's just go through this then. So the next thing that's going to be the easiest equation to input is our elevation equation. And remember, I went over this at the very beginning of class, just to make sure that everyone is at least familiar how we would calculate elevation. So this is how you're going to do it in Excel. So the elevation is just equal to the elevation of the benchmark plus the vertical distance minus the vertical distance to the benchmark. Now, the important thing here is that you have to absolute reference the benchmark elevation and the elevation to the benchmark, because regardless at point 1, point 2, point 3, point 4, that's all the same. That's never changing. And if I drag and drop this equation down, see, now it's referring to B5, and in the next, now it's referring to B6, now it's referring to B7, and that's the beauty of Excel. So in order to keep our absolute reference, we want to put the $sign in front of the C, in front of the 1, as well as in front of the E, in front of the 1. That's called an absolute reference. That means that even if I drag and drop this equation down, it never changes. You can see that those cells are always highlighted. So that's awesome. That's what we want. Now, our easting and our northings are going to be a little bit more complicated. The upshot is that you need to use a trig function in order to calculate your easting and your northing. Why do you want it in this? You want it in this format because you want it in XY format. That's what Excel, or that's what AutoCAD likes. That's what makes AutoCAD happy, and we want to make AutoCAD happy. Let me see if I can get into my meeting again with my iPad. I want to go over something kind of important. Well, a couple things that are important. So the first thing is AutoCAD, or not AutoCAD, I'm so sorry. Excel doesn't believe in degrees. Everything has to be in radians. So if let me just kind of pull this to the side over here. If I want to have an equation where I say, if I want the sine of 30 degrees, how do I start an equation in Excel? I use the equal sign, and then I want sine, the SIN, not the SIGN. And you can see that Excel gives you a drop-down list of different functions. So sine, open parenthesis, and it wants the sign of a number. Well, let's say I put in 30. Okay, that doesn't really mean much, does it? So what you have to do, you have to say, for an angle, radians of that angle. And that's what we want. Sine of 30 should be 0.5. So anytime you use a trig function in Excel and you give it an angle in degrees, you have to put that angle inside the radians function. That makes sense? It doesn't make sense why they did it that way, but does it make sense as far as how you would write an equation? So let's let me do another example over here on this clear space. So we have something recorded that you can go back to. Let's say that I want to plot the sine function. How would I do that? Well, Excel is all about having columns of data, and we're going to write equations in another column. So let's say I have some data. So I have my degrees, and I have 0, 1, 2, 3, and let's say I can highlight those first three. Excel recognizes the pattern, and I can pull that down. Let's say that I want to go all the way to 45 degrees. So as we just mentioned, Excel does not like degrees. So I want to convert that all into radians. So equal sign converts degrees to radians, and we're just going to make it refer to that cell. Close parenthesis, 0, excellent. Now we can double click that little toggle in the bottom right hand corner, and it converts all of those numbers for us. Now let's say we want the sine. So this is just going to be equal sin, open parenthesis, and it wants a number. The number that it wants is the radian. Enter, and we can drag it all the way down. Now, this is besides the point, but let's, what does that look like if we plot it up? Don't worry about plotting stuff in Excel for this class. I'm just showing you. That somewhat look like a sine function starting to curve. Did I plot that correctly? Yeah. So I could go even further, right? I could pull this all the way down, and I could plot all the way to like 120 degrees. Cool, you can kind of start seeing it curving over more a little bit. Oh no, it didn't do it for some reason. I'm sorry. Messing this up. This is supposed to be a fun little side. Yay, there we go. Cool, so yeah, like as you can see, I'm plotting discrete points, but by plotting those discrete points, I'm trying to get a sine function. Isn't that fun? I need someone to affirm me here that this is a little bit fun. Yes, I am a geek, Kenny. I love a good spreadsheet. And that's why I'm still in school. Okay, so my point in showing you all of that is that if you want to insert an extra column before your east coordinate or your north coordinate, you just right click. You can write insert. Ooh, and you can say like radians. And you can say equal to radians. Sorry, my computer has like 5 things open right now that take a lot of power. So hopefully it doesn't crash. Okay. So you can immediately convert that to radians if you want. That way you don't have to do it all in one big long line. Cool. Does that make some semblance of sense? That you need this decimal degree in radians in order to do math in Excel. And remember, you have 4 weeks to do this. I'll have office hours. Cool. Again, a couple thumbs up. That's all I need. And so you have 4 weeks. I have office hours. If it's a little unclear now, just zoom into an office hour, and I'll help you out. It's not a problem. I live for this. Anyways. So I guess the clue that I'm going to give you for the X and Y coordinates is that you might need to use like an if statement or something along those lines in order to get the correct SIGN on your coordinates. So let's just think about that for a second. So if I am turning my angles this direction, and this has an easy, should this be a positive easting or a negative?
We can't see what you're referring to.
Oh, no? I'm so sad. I'm so sorry. My iPad is having some issues today. Now, can you see me?
Yes.
Yay! Okay, so if we're turning our angles from our north, and we had, and our instrument is at the origin, so that's clearly positive. Positive. What about this point down here?
Positive, negative?
Yep, positive easting, negative northing. And then this one.
Negative, negative.
And then the last one.
Negative, positive.
So do we look at our horizontal angle, decide what quadrant it belongs to, and then pick the signs, right?
That is definitely one way that you can do it. That's the way that I ended up doing it. Because this would be like, let's say 45 degrees. This one is more like, maybe 110 degrees. This angle, right now we're like 200 degrees. And this angle is going to be, in the 300s. So, and that's how all of the data is going to be given to you. It's going to be given as an angle between 0 and 360. And you have to make sure that you get the right positive, negative on it. Now, the way to do that, my favorite way of doing things, is doing it incrementally. Before you actually try and plot all of the data, make up some data. Make up some data where you know the answer. So, for example, I know that if I have 10 degrees, it's going to be up here, right? It's going to be up in this quadrant. I know that if I have a piece of data that I turned 100 degrees, I know it's going to be over here in that quadrant. Similarly, I know if I have a piece of data 190 degrees, it's going to be over here. If I have a piece of data that's 280 degrees, it's going to be over here. So before you go all out on plotting all this up, just make up a couple points where you know the answer. And that's what I've done in this sheet where I was trying to get it to work. I just made up some values to make sure they would plot correctly in AutoCAD. So, wait, to summarize all of that, I know I've been talking a lot, guys. I'm sorry, people. To summarize all that, you're going to convert things to decimal degrees. If you want, you can add an extra column to convert that to radians. You're going to convert that into easting and northings. You're going to come up with some way of getting those coordinates. And we're going to use that elevation that I went over earlier to get your elevation. Now, here is the super cool part, is that you can enter in the data for the point and the data for the text all in one line into AutoCAD. But it has to be in a very specific format. And I will give you an example of the format in the sheet that I send out. So the first, remember the first command is point, and then there needs to be a space. This is the easting. It has a ton of decimal places because it's from the Excel calculation, so don't worry about that. Yours will too. It'll have a ton of decimal places. Then it has a comma. Then it has your northing. And then it has a space. Text, space. Then it has the same coordinates because you want your text to go at the same coordinate. 0.125 refers to your text size. 0, then space. 0 refers to the angle of rotation. So 0 is fine. You could also do 90, then space. And this last number is the elevation. And that's how it has to be, that exact format in order for Excel, for AutoCAD to be happy. How are you going to do that? You're going to use the concatenate function. C-O-N-C-A-T-E-N-A-T-E. I guess concat is the new one. I use concatenate, but apparently that's an old version. You're going to use concat. That's the function that you're going to use to create this text. I won't give anything more away. Again, we have 4 weeks. Please come to my office hours. You're going to work in groups of 2. So if you want to divide and conquer, go for that. But this Excel file will be part of your deliverable. So now, why did we go through all of that effort? Well, because we can do it one time, and then we can just, I want to show you the equation. So we can do it one time, we can click on it, and then we can drop it down. And then that way, it's going to make a single line for every single point. The next thing that we're going to do is that we're going to highlight all of our points. We're going to copy them. Now what we're going to do, we're going to make a text file. So place this text file wherever you are placing the rest of your AutoCAD work. You're going to open your text file and you're going to paste all of that in. Paste it, Control S, save it, and X out. Now, what we're going to do is we're going to change TXT to SCR. So if you don't see the file type at the end of your file, you can change that under your properties. So we're going to go to TXT. We're going to change it to SCR. It's going to get angry at me. You say, yes, I am sure. And as you can see, it'll change to a little AutoCAD file. All right. Let's, what now? Well, we're going to come back to AutoCAD and we're going to type SCR in my command line. And it's going to say script. I'm going to press enter. I'm going to go to my file and I'm going to click on the script that I just made and press open. Boom. You can see it just added all of those points. And, oh, it didn't add, oh, the text. The text is really small. Yeah, we can change that. But as you can see, it added the points and it added the text. Isn't that awesome? Woo! Okay, 1 thumbs up. That's all I need.
Can we do it one more time by any chance?
Absolutely. Okay, and remember, this will all be recorded. So you're going to create, and I'll give you an example, but you're going to use the concatenate function in Excel, and you're going to create a line of text. I put it to the side because I don't want you to see the function. You're going to create a line of text that has this exact format with the spaces and commas all in the right place, where it tells you the point, the easting, the northing, and then the text. The easting, the northing, the font size, and the text label.
We might as well change it right now if we are redoing it, like give the 90 degrees for text and like slightly larger. Where by, yeah, I can see it. Slightly larger font size instead of 125, like 5.
Yeah, I have it as 1/8 of an inch because that's like standard for paper space. But yeah, you're gonna want to change that. But I'll show you a neat trick to change that in AutoCAD. Yeah, because it is really small. So once you do that, you're going to select all of those lines that you just generated. So you're gonna, and I'm going to put this to the side so you can't see my equation. I'm going to select all those points, Control copy. I'm going to create a text document, new text document, whatever. I'm going to open it up. I'm going to Control paste. Then save it, close it, change the file extension from txt to scr. Say yes, I'm sure. Let me get rid of these points. So that's all we have to do there. Now we're going to open up AutoCAD, come to the command line, and type scr. And as you can see, it automatically is suggesting that we use the script command. We just press enter. And use the file navigation to find wherever your text document is. You click on it, open, and it automatically adds all of those points.
Okay, I think I got it now. The reason you are doing it as a script, not as importing points, is because you have text attached to it and some other like nice things, right?
Yeah, so it has the points and text. And so there's all sorts of ways to do things in AutoCAD. I just thought this one was a pretty neat way to do something that in the past we've always done by hand. So, I mean, every company that you go to, whether it's surveying, geotech, whatever, they're going to have their in-house scripts that somebody has already written, and that's going to be proprietary to that business. You know, so I mean, this is pretty common that if you work at a company, and this is a very, very common type of work, but if it's a new project, like I have friends that, you know, if they're working on a project for, I have a friend that's working on a project in Canada right now, and he is automating everything in Excel to print out a data report sheet, given the real-time information from the drillers. So, you know, it's pretty common to use different Excel sheets in order to generate data. So one other thing that I mentioned is that I put these in really, really small. So that's tiny. And that's not going to really work with my scale. Chat. I did not show how to get the I did not show how to get the coordinates. So that's part of the assignment, is that everyone's going to have to figure out with their team. And I'm happy to help. You just have to come to my office hours, and it's due in a month, so we'll have plenty of time to work together on those equations. So yeah, the last thing is that these can be very tiny. I guess two things. Oops. These are very tiny. You might want to have those be bigger. So we're going to come down to our command line and say select similar. And we're going to select the object. In this case, is text. We're going to press enter. And as you can see, all of the similar text has been chosen. So we can go to properties. We can go to height. We can make it like 3. Boom. There we go. So that's a fast way to change all of a particular style. So all right. The final thing that I'm going to cover, I promise, is drawing in the contour lines. So make a layer for contour lines. Oops. I guess I already had this drawn in. And the way that we're going to draw our contour lines is with the polyline function. Choose the polyline. So let's look at some of this data. We have 23 feet, 22 feet, 30 feet, 40 feet, 50 feet, 50 feet. So clearly the elevation is increasing to this direction. Now let's say that I want to do 5-foot contours starting at 25. Well, okay, there's a 22 feet there and a 30 feet there. So 25 is going to be somewhere in between them because we assume that the elevation increases linearly between any 2 data points. So we would start our line about there. Well, our next data point is going to be somewhere over here, right? Because we have a 23-foot elevation there, 40-foot elevation there, which means that the 25-foot mark is going to be about there. This doesn't need to be perfect. In reality, there's software that would draw this all in for you for Civil 3D. Even when software draws it in, it's not great. Like you have to go in and hand correct it. The software definitely isn't perfect, so it's really good to think through where the things should be. So honestly, you could just draw a single line through here, and that would be your 25-foot contour line. And let's say I actually want to have an additional layer for my contour text. So let's make that. What color is it going to be? Let's say it's going to be white. Okay. And we're going to just do a text annotation. And we're going to just write 25 feet. Oops, way too small. So A, that's too small. It's on the wrong layer. So we're just going to select it. And we're going to put that on our contour text layer. And if it's too small, go properties, right click properties, text height. Yeah, let's make it like 3. Probably want to make it even bigger. Awesome. And it's as simple as that. So you do the same for your 30-foot mark. This one's a little bit easier because we know it has to go through this 30-foot point. There's 22 feet there. There's 40 feet there. That means that our 30-foot mark is going to be halfway in between. That's where that line comes from. And we know that our 23-foot is there and our 40-foot is there. So again, our 30-foot mark is going to be approximately halfway in between. And you can even copy and paste once you do a single. And that will be 30 feet. Awesome sauce. Is everybody all AutoCAD'ed out?
I'm not quite sure. Do you want us to figure out how to do these contour lines through AutoCAD, or do you want us to draw them manually?
When you say manually, do you mean by hand?
Like you just did.
You need, yeah, so you're gonna have to draw them manually. AutoCAD doesn't, unless if you have a special version of AutoCAD and special software add-ons, you can't have them
Oh,
in.
I thought it did it for you somehow.
Civil 3D can do it for you. So I guess I would add, this is one of those cases that if you're very comfortable with different versions of AutoCAD and you want to go through the time and effort of figuring out how to use another version of AutoCAD to do contour lines for you, absolutely. That's great. But otherwise, what you're going to have to do is you're going to have to come in and you're going to have to interpolate in between points. And you're going to have to choose your major interval, and you're going to have to draw these lines in using the polyline function. And like I said, it's a good thing to know because even the programs, even like in Civil 3D, when it draws them in for you, sometimes they can be pretty wonky. And you have to come in and interpolate anyways. So that's our crash course in AutoCAD, Excel, and then AutoCAD again. So what I'm going to post is this handout. Shown here, that's the procedure. It's just there for reference. So we're not actually going out in the field. The thing that we care about is the computation and mapping. So the data is going to be provided in Excel format to perform calculations, or if you're a open source kind of person, awesome. I really prefer Excel for your final thing, but if you do it in Google Sheets or whatever, that's fine. But Excel is really where it's at. So you're going to use a concatenate function in Excel to join together the point data and text data. You're going to create an SCR file from that data and input those points into AutoCAD. Remember, as Kenny pointed out, AutoCAD, especially the generic version, you're going to have to input everything in inches. So it would behoove you to do that conversion automatically in your initial Excel file. The CAD file is going to need to have the following information: all of the points. Points should be in their own layer. I showed you layers. And every point should have an individual point elevation in its own layer. Drawing features such as buildings, walkways, etc. And I gave you the pin so you can go check out that area. You need contour lines created by CAD, or if you want, if you're a super, if you already have experience, use Civil 3D. Really, regular AutoCAD polylines is where it's at. You want major lines, minor lines. You need a title block, and that's going to be in your layout space. Legend, any necessary callouts. All a callout is, it's just a written note on your drawing. And then either a scale bar or a written indication of the scale at which you chose. So what we're going to turn in December 5th. Actually, let's change this even again, because realistically, I'm not going to get everything posted until Monday morning. So let's say that you have until the 7th. December 7th. So you're going to have your topographic map as a PDF. So in AutoCAD, you can go to, when you go to print, one of the options is, where is it? I may have chosen the wrong. Publish. So in AutoCAD, gosh dang it, it's not. It is under print. Under print, there should be an option in here somewhere to print it as a PDF. Okay, I'm not seeing it. I'll post that later. There is.
Could it be export by any chance?
Yeah, it might be under export. You're right. Yeah, export. Yay. Thanks, Olga. Okay, so export is PDF. And then you can, call it drawing, whatever, your name, your partner's name. And then that's how you're going to turn that in. You're going to turn in your Excel sheet just as the file with your name and your partner's name. So yeah, Excel file with all the functions and calculations in there. So don't copy paste it with just the values. I want to see your Excel equations. And then email me the CAD file in DWG format. All right, I know it seems like a lot, especially if you're newer to AutoCAD. You have a month to do this. I would start on as soon as I get things posted, which again, realistically, I'll get that posted on Monday morning. So you'll have a month. I will have office hours. When would be, I guess, our last thing is, when would be a good time for office hours for everyone for this project? Because I don't want to do, I think it'd probably be easier during the week. Does Tuesday late afternoon work for everyone? Or for most people?
It works for me.
Okay. And, so let's say Tuesday, 4 o'clock, I'll do office hours. Marcine is also available during her office hours. Yeah, so Tuesday, 4 o'clock, I'll send out the Zoom room for office hours. And if that doesn't work for you, just shoot me an email. And we can figure something out. I'm pretty free, especially in the evenings. So no problem there. Okay.
Kyle?
Yep.
Kyle?
Yep.
Just real quick, I know that different versions of AutoCAD have incorporated different things. And taking a look at the AutoCAD 2021, and there's a feature that I think you'd like. And it may have popped up in your version as well. If you go to units, you can actually select surveying feet. So see where it says inches? Go down a little bit.
Yeah. So this is the insertion scale, which is so that's when you put
So
things
we,
into the drawing. So if I copied something over from another drawing, I would want it to have it in surveying feet. Yeah. And it would automatically scale it to this particular model space.
right. I was figuring that would probably save everybody multiplying by 12 and all that in Excel.
Yeah, so it doesn't actually, I've tried that before. So that doesn't change the underlying size of the units of the model space. It changes when you insert, if I inserted something from Civil 3D that was in feet and I insert it into this drawing, it would automatically scale it by 12.
Okay.
Yeah, it's there. So again, this comes into I know that there are better ways of, like, you can go into the AutoCAD settings and change some of these features. Like, I could change it to all be in feet, and that might be a little bit easier. But then I would also have to change my paper space units. So there's definitely a little legwork to be done in AutoCAD. Different versions have different functionality. Um, However you want to go about doing it, as far as inserting your units, that's fine. I'm most comfortable just multiplying everything by 12. Yeah, and if you figure out a better way of doing it, absolutely go for it. Cool.
Yeah, with AutoCAD, there's usually about 3 or 4 ways of doing almost anything. So whatever is you find comfortable is good.
Yeah, exactly. And so everyone doing this, like, if you find another way to do a similar thing, you're welcome to do it. Even if you figure out a better way to input all of your data at once, do it. But you do need to put all of your data. You do need to use like a script function to put your data in at once. That is the requirement here. So whether or not there might be a better way, I think that you can use Lisp even to read directly from Excel. So, don't go down a rabbit hole and spend 20 hours trying to figure out the deep dark secrets of AutoCAD. But if there's something else that automates it faster for you, please do it. Cool. So the things that I need to post for you all is, this Topo lab that tells you what you need to do, what you need to turn in. I will get you the Excel file by Monday morning. I still need to input some of the data points. Yeah, for anyone that wasn't here at the beginning of class, if you have a 0 on one of your assignments, it's probably because you turned it in some weird file format that I couldn't read. So if you have like a 0, just go check. I probably just ask you to resubmit it like as a JPEG or a PNG. So that's that. Anything else? Any other questions? Oh, I've also mentioned this like multiple times, but I haven't done anything about it. You're gonna be working in groups. So please work in groups of 2. If you want to take a few minutes to message each other in the chat, go for it. I think that there's 10 to 12 people still actually actively part of this course. So I think it'll work out fine. So yeah, I'll stick around for probably like 10, 20 more minutes if anyone has any specific questions. Otherwise, please use the chat feature. You'll find someone to work with. And or I can just assign people, but yeah, see who you want to work with. Shoot me a Canvas message by Monday saying who you're going to work with. And yeah, I'll get everything posted by Monday and we'll have a whole month. Woohoo. Thank you, everyone. I'm going to stop recording now.